Hello, good afternoon, good evening, good morning, whenever you are watching this video. Now, so in the last class, I have completed one topic in general organic chemistry, and the name of the topic is called inductive effect. Now, today we are going to see the next part of the topic, and the name of the topic is hyperconjugation. Before teaching this topic, I have to teach you something. Do you know what do you mean by electrophile? Electrophile. Electrophile is those species which is electron deficient species. It is electron deficient species. Electron deficient species, and electrophile can be denoted as E plus. It doesn't means कि all the positive charge are electrophile. I have dictated you in the first class of GOC कि some is formal charge, some is vacant orbital. If you have not seen, watch it properly. Means suppose I will write BCl3. This is electrophile. You will say yes sir. BCl. It has one vacant orbital. It means it needs electron. So those who have electron deficient species, those who are electron deficient species, what they want? They want electron. Why? To complete the octet. To complete the octet, they want what? Electron. It means electrophile is electron deficient species and it is a electron lover. Okay. Suppose I will write Al3 plus. It is also electrophile. It is electron deficient species. 3 electron is less. First you understood electrophile. Now we are going to start one topic, and the name of the topic is hyperconjugation, because use of electrophile is there in the hyperconjugation. First of all, understood कि hyperconjugation is also known as no. First name understood. Hyperconjugation is also known as no bond resonance. Why? I will tell you. Don't worry. It is also known as Nathan-Baker effect. Nathan-Baker effect. Why? I will tell you. Don't worry. So hyperconjugation is also known as no bond resonance, and it is also known as Nathan-Baker experiment. Why no bond? Why Nathan-Baker? We will understood. What happens now? There is a scientist whose name is Nathan and Baker. Two scientists. One name is Nathan. One name is Baker. These two scientists is doing one experiment. Now why they are doing experiment? Just now they have studied inductive effect. So he is started doing one experiment. He said, okay, just now we have studied, we have seen about one topic, and the name of the topic is called inductive effect. Now he is going like that. You have seen na, कि whenever J.J. Thomson has completed the experiment of atom is whole electrically neutral, as well as eating part, edible part is the red part, and the seeds are embedded in it, but Rutherford has made them wrong. Similarly, over here, first Nathan Baker is come to check. We have, again, don't get confused. Yes, very good morning, good afternoon, good evening, boys. Whenever you are watching this video, what I am trying to say, first of all, before knowing resonance, we have to know that resonance is also known as no bond resonance. Resonance is also known as, first of all, before going with the topic called hyperconjugation, we have to know that hyperconjugation is also known as no bond resonance, and it is also known as Nathan-Baker effect. Now I have dictated you electrophile. Electrophile is a electron deficient species. It means it is a electron lover. What is electron deficient species? We know already. Now I am saying that just now Nathan Baker has completed the study of inductive effect. Inductive effect has been discovered. Now Nathan Baker come to the point and doing one experiment to see how the inductive effect will work over here. But he will get something different. What do you mean by that? I will tell you. Over here, Nathan Baker just completed the topic called inductive effect. After completing the topic, suppose this is P, this is Q, this is R, this is S, and he decided to do one experiment. What is the experiment? In the experiment, he tried, he not, they write, because not one scientist, two scientists is there. They try to attack electrophile on benzene. They try to attract electrophile on benzene. What he thought, कि we have studied just now plus I effect, and according to plus I effect, what has been taught to us कि 3 degree alkyl has more inductive effect than 2 degree alkyl, then 1 degree alkyl, then simple methyl. So he thought कि over here we have 3 degree alkyl, so it will show too much plus I. Over here it will show too much 3 degree, so 3 I will make. Over here 2 degree, so it will show some other I effect. Over here it will also show some I effect, and very less I effect it will show. Now I effect means electron density coming inside the ring. So where the electron density will come according to the hyperconjugation? Again, don't get confused. First I have dictated you the topic, and the name of the topic is called hyperconjugation. Before dictating hyperconjugation, I have dictated you electrophile, and hyperconjugation is also known as no bond resonance, and it is also known as Nathan-Baker effect. What the Nathan-Baker has done, he has taken benzene ring. You know that. What is the name of this compound? Toluene. What is the name of this compound? Ethyl benzene. This compound cumene. Understood na? You didn't know, try to see it. This is cumene. Okay. And this is tertiary benzyl. Now over here, understood again a story properly. Nathan-Baker thought कि in the last part, S part, too much plus I is coming. It means electron density in the ring increases. What is increases? Electron density increases due to plus I. Now as the electron density increases, and if I will attack electrophile, so what he thought, his expectation, he expected that rate of electrophile, in which structure electrophile will attack more. So he thought कि in the S part more number of plus I is there, then R part, then Q part, then P part. It means in S more electrophile will attack because inductive effect is showing by the 3 degree. So in the ring, benzene ring, too much electron will increase, and due to the increase of too much electron, electrophile needs electron, so they will go on S part, then R part, then Q part, then P part. He expected this. He expected this part, but total moe happen. What will happen? Moe happen means he observed after doing the experiment. He observed after doing the experiment कि no, this is not happening. In absorption part, he got कि P has more than Q, then R, then S. It means in P less inductive effect, still more electron density will be increased in the P ring. Why it is so, sir? So he thought that inductive effect is not sufficient. Inductive effect is not sufficient. So from there the concept of, or you can say the birth of hybridization. So there is a birth of hybridization. Again. Nathan-Baker is doing one experiment. While doing that experiment, he had just now studied hyperconjugation. Just now studied the topic, and the name of the topic is called inductive effect. After studying inductive effect, he thought कि over here in the third carbon too much I is there, 3 degree alkyl is there, so more electron density increase in the ring, and because of increase in the electron density, what will happen कि electrophile will attack more on S, then R, then Q, then P. But he observed, what he thought opposite, he observed कि in P it is more, S will be less. So from here he thought and understood that inductive effect is not more than enough. So he has derived the another concept, and the name of the concept is called hybridization. So it is also My mistake. Not hybridization, sorry, hyperconjugation. कंफ्यूज नहीं किया ना, बाय मिस्टेक लिख दिया सर. हाइपर कंजुगेशन. अब नाउ फॉर दिस ओनली आई विल नॉट गोइंग टू स्टार्ट द टॉपिक अगेन. अंडरस्टूड ना. अगेन लास्ट पार्ट. हाइपर 10 मिनट already gone. Electrophile understood. Nathan Becker has done one experiment. He thought in the S part more electron will attack because more plus I, in R less, Q very less, P very very less. But he observed that no, which has less plus I, they have more electrophile is attacking in the ring because electron density in the ring is too much. So he thought hyperconjugation is not the only sufficient effect to describe it. So he given the birth of hyperconjugation. So hyperconjugation is also known as. So hyperconjugation is also known as Nathan Becker effect. Nathan Becker effect. See, once you will understand the topic, everything will be very 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 easy. So I hope you understood why to study hyperconjugation and why the name of hyperconjugation is also called Nathan Becker effect. Now see what is happening in the case of hyperconjugation. First of all, before studying hyperconjugation, I hope this everyone knows. Suppose I will draw like this, or like this, 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 and I am writing over here plus sign. With respect to this plus, this is alpha carbon. After that carbon is beta carbon. After that carbon is gamma carbon. Every side, left hand, right hand, up, down, every side you have to check. With respect to this plus, it is alpha carbon, it is beta carbon. With respect to this plus, this is alpha carbon, this is beta carbon. If I will go down, this is beta carbon, this is gamma carbon. So with respect to this plus, what is alpha carbon, what is beta carbon, and what is gamma carbon? Understood the point? So adjacent to that carbon is alpha carbon. So how many alpha carbon you have? Sir, I have 3 alpha carbon. One is here, one is here, one is here. 3 alpha carbon. Understood? Alpha carbon means. Now next, what is happening in the hyperconjugation? Up to now any confusion? No sir, we understood it. Okay, don't get nervous and confused. Now in hyperconjugation what happens? You have seen fan. Suppose I am writing some structure over here, CH3 CH2 plus. Now see the topic very very properly and clearly, because I personally believe and hope those who will try to see the topic properly, for them every topic, every question is very easy. Those who just want to know number of alpha hydrogen is the number of hyperconjugation, that is bakwas. Just see what I am trying to say very properly. The first you understood what is electrophile, and second you understood how the birth of hyperconjugation happens because of inductive effect fails over here. Some new concept coming. So why it is known as Nathan Becker also understood. Suppose it is there. You have seen fan. Fan you have seen? Yes sir. If I will draw this like a fan, this is fan, and this hydrogen is a blade of fan, is hydrogen. Ab now over here CH2 is there, and in CH2 I have written plus sign, means it has vacant orbital. Ab now this fan will rotate, dung 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 dung, like that this fan will rotate. Due to the rotation of this fan, what will happen? Ki sir, sometime this hydrogen is going this side. After rotating, this hydrogen will come this side. After rotating, this hydrogen will come this side. This side coming means what? This hydrogen is giving the electron to the vacant orbital. This hydrogen is giving the electron to the vacant orbital. This hydrogen is giving to the electron to the vacant orbital. So means it is fan like. Means suppose I will take the example like this. Just see the very properly things. Suppose I have taken the example like this. Ki carbon is there, hydrogen, and hydrogen is there, and over here CH2 plus is there. So first this hydrogen will come here, and because of coming to this hydrogen, what happened? H plus will go outside, carbon is getting negative, and that negative will come as a double bond, and CH2, this electron is giving here na, they are giving the electron from here to here na sir, because of giving over here double bond coming. So see over here hydrogen is still present over here without the bond. there is no bond between carbon and hydrogen, but H plus is there, so it is also known as no bond resonance. Similarly, in the second case, this hydrogen will come here. What will happen? Sir, carbon over here, this hydrogen is already attached, H plus, this is attached, double bond CH2. Third situation, it will happen कि the last hydrogen will come here, and due to the coming of last hydrogen, first is attached, second is attached, plus double bond CH2. So this is known as hyperconjugation. This concept is known as hyperconjugation. Understood now? It means the hydrogen itself giving the electron to the vacant orbital. So which will show hyperconjugation? Some understanding na, not that much tough topic na. Okay, suppose I will write boron, I will write plus, I will write dot, I will write minus, I will write double bond, I will write triple bond. I will ask, boron will show, yes sir, it has one vacant orbital, and in hyperconjugation electron is given by some other element from alpha position, so that vacant orbital will take yes. Plus means also vacant orbital. Dot means one unpaired electron is there, it will also give. Minus, no, it is already justified, it has more electron, so it will give to someone, it will not take. Double bond, yes sir, double bond will also show, triple bond will also show, because double bond will break like this. Over here plus will come, over here minus will come, so this plus is indirectly a vacant orbital. Over here triple bond is there, this will break, it will get minus, it will get plus. On this position there is a plus, vacant orbital, means hyperconjugation can be only and only seen by boron, plus, dot, negative no, double bond and triple bond. And how hyperconjugation will happen? Understood the point or not understood? Fast. So we will just see it once. I am going to dictate the definition of this. If we will see the definition, what is definition saying? When vacant orbital like C plus, B, C dot, alkene, alkyne are present next to sigma bond, and the sigma electron of CH bond delocalized to the vacant orbital. Sir, this definition not coming. Just understood my ways. This definition I have just copy paste, because PDF also I am uploading na. So for that purpose I have written this definition ki after some time you will study, you will not find any difficulty. What I have done, I have written CH3, CH2 plus, fan will go, one hydrogen will go from here to here, and what I am writing, CH2 double bond CH2 and one hydrogen as H plus coming outside. Means first part, carbon, hydrogen, 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 electron is present here in the carbon hydrogen bond. Now electron will go in carbon carbon bond. First point, understood everything? First point you will write, I have written na, ki there are three permanent effects. One permanent effect is inductive effect, another one is hyperconjugation, and another one is resonance. First point you will write ki it is a permanent effect. It means what is the definition I have written, I am going to justify all the definition in my own language. Second point, oh, previously in inductive effect there is a shifting of electron, but over here there is a transfer of electron. Yes sir, there is a transfer of which electron? Sigma electron. From where the electron is going? From sigma bond going. The transfer of sigma electrons. Third one. Acha. Previously shifting of electron, the atomic orbital of electron not changing. But over here, previously the electron is present in carbon hydrogen. Now electron is going in carbon carbon bond. It means atomic orbital of electrons changing. What is changing? Atomic orbital of electron changing. Fourth one, what you will need over here, it is valid for sigma bond, pi bond or sigma bond only. So I have written inductive effect is only valid for sigma bond, resonance is only valid for pi bond, but it is applicable for sigma and pi bond both. So I have written that it is applicable for alkene, alkyne as well as plus and minus. Acha. After that, fifth point I can write कि it is a strong effect. Previously I have written कि permanent effect is 3, inductive effect is weak, hyperconjugation is strong, and resonance is super strong. So it is a strong effect. Understood this point? Means overall, if I will go and I will check, so what I will say कि sir suppose, and 6th point also you can write कि there is a delocalization of sigma electron, same thing, transfer of electron, sigma electron, or I will write delocalization of sigma electrons to sigma electrons, direct, same. 6th number definition and second number definition is same. So what I have written over here, their meaning is this 6th point. I have written a 6th point, that will be meaning this. Suppose I will ask first question. Over here, I have given plus charge. So understood what I am saying. You have to check that there is a alpha carbon. You have to check alpha carbon, and that alpha carbon will be sp3 hybridized. That I have make you confused? No sir. First of all, I have dictated you electrophile, that is electron deficient, electron lover. Nathan Becker experiment, after studying inductive effect, he thought कि S will be more than R, will be more than Q, will be more than P because of plus I effect, but it is coming opposite. So he has given the one new concept of hyperconjugation, so it is known as Nathan Becker effect. Over there, with respect to plus charge, I have dictated you which one is alpha carbon, which one is beta carbon, and which one is gamma carbon. Then I have dictated you कि fan blade electron is going like that. This is the structure of hyperconjugation. Hyperconjugation is valid in this, it is not valid for negative charge. Then this definition I have dictated you, it is a permanent effect, transfer of sigma electron, atomic orbital of electron changing, because previously electron is present in carbon hydrogen, now electron is going from carbon hydrogen to carbon carbon. After that, I have dictated you, it is valid for sigma and pi bond both, it is a strong effect. And second point, transfer of electron and delocalization of electron is same. Then you will add this as a 7th point, that where there will be a vacant orbital, adjacent to that vacant orbital there is alpha carbon, and that alpha carbon will be sp3 hybridized. I will ask, it will show hyperconjugation? Yes. 8th example, suppose not point, now example, it will show alpha hybridization? Yes sir, there is alpha carbon, on that alpha carbon it is sp3 as well as it has hydrogen, it will show hyperconjugation. Suppose I will take this example. Yes sir, it has alpha carbon, this one, and this alpha carbon is sp3 hybridized, and as well as it has hydrogen, this will show a hyperconjugation. Suppose 10th example I have taken CH3 CH2 minus alpha carbon to there, and that is also sp3, it has also hydrogen, but problem is there here negative charge, and we know that negative charge will not show hyperconjugation. Suppose I will go with question number 11th. In 11th question I have written CH3 B CH3 H, it will show hyperconjugation. You will say yes sir, it will show hyperconjugation. How? Sir, it has this alpha carbon, it has this alpha carbon, either from this side the electron will come to vacant orbital, or from this side the electron will come to vacant orbital, and alpha carbon is sp3 as well as alpha carbon has hydrogen, so it will show hyperconjugation. Understood? Which will show hyperconjugation and which will not show hyperconjugation, everyone. Now I am going to write some questions to find total number of alpha hydrogen. What to find? Total number of alpha hydrogen. Again understood. Over here, when I have dictated you this structure CH3 type, this structure I have dictated, it has, suppose this structure, I will draw it again. Suppose there is a structure CH3 CH2 plus. What you are doing? You are saying, sir, I am writing this structure like this, and over here CH2 plus. Now if you will draw the structure, what you will say? Sir, C H plus H H double bond CH2. Again what you are saying? Ki the middle hydrogen will go CH H double bond CH2. Again you will show, sir, third hydrogen will go H H H plus double bond CH2. If anybody is asking what is the total number of hyperconjugating structure involving CH bond, what you will say? Ki, sir, it is equal to the number of alpha hydrogen. This carbon has alpha carbon is sp3, and it has how many hydrogen? 3 alpha hydrogen. So you will see 1 2, 3 hyperconjugating structure is possible. Understood the point, everyone? Now I am going to ask how many number of hyperconjugating structure is possible for the given example. After that, we will see the hyperconjugation experiment that is done by the scientist whose name is Nathan Becker. Over here he failed, so we will see over here also hyperconjugation how will be happened. Now we are going to see some more questions regarding the topic. If we will see the question over here, they are asking the question, tell me how many total number of alpha hydrogen present, and I am adding the question, number of hyperconjugating structure. So if double bond is there, close the double bond. After closing, check, this is alpha carbon, this is alpha carbon, this is alpha carbon. How many hydrogen is present on each carbon? Here 3, here 3, here 3. So 9 alpha hydrogen. 9 alpha hydrogen means 9 hyperconjugating structure. Understood? Suppose over here we have to check to close this triple bond. This is alpha carbon, this is alpha carbon. How many alpha hydrogen? 5 alpha hydrogen means how many hyperconjugating structure? 5 hyperconjugating structure, because I have written total number of hyperconjugating structure involved CH bond is number of alpha hydrogen. Suppose I have to check for this to close this part plus charge. After closing, alpha carbon this one, alpha carbon this one, alpha carbon this one. This alpha carbon contain 2 hydrogen, it will also contain 2 hydrogen, it will also contain 2 hydrogen. So 2 3 is 6. 6 alpha hydrogen, it means it has 6 hyperconjugating structure. Over here if we will have to check, draw like this circle. After that, this is alpha carbon, this is alpha carbon, this is alpha carbon. This alpha carbon contain 2, this contain 2 hydrogen, this contain 1 hydrogen. So 2 to 4 1, 5 alpha hydrogen means it has 5 hyperconjugating structure. That is the number of alpha hydrogen is the number of hyperconjugating structure. Here close it. After closing, this is our alpha carbon. This alpha carbon has how many hydrogen? 0 alpha hydrogen. Why sir? Because this is carbon, 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 4 bond done na. So it has 0 hyperconjugating structure. Suppose I have to check this part, close it. After closing alpha carbon, after closing alpha carbon. Just adjacent to that, don't see this, don't see. Over here, how many hydrogen? 1 sir. Over here, how many hydrogen sir? 3. 4 alpha hydrogen. So how many alpha hyperconjugating structure? 4 hyperconjugating structure. Understood this part? Everyone, see once, then I am going to dictate you the remaining part of the topic. Understood this part? Now see, slowly I am going to draw each and every atomic orbital, matlab each and every hyperconjugating structure. See over here very properly. Then at last we will do all the questions. Topic done. Moe life will be hyperconjugating structures. I will not draw all possible structure. Up to now you have understood. I hope so. Another revision will kill me, you all. Over here we have CH3 and CH2 plus. First we are going to see for cation. Hyperconjugating structure in cation. Now what is happening over here? This electron is going. Which electron is going? Sigma electron. Where going? Vacant p orbital. And then you are making H plus CH double bond CH2. Like that you will do with another hydrogen. It means if anybody is asking you what is the orbital overlapping approach. Orbital overlapping approach means from where the electron going to where. You will say electron is going from sigma bond to p vacant orbital. See, carbon plus is p vacant and CH bond is sigma bond. So sigma bond to vacant p orbital is the cation hyperconjugating structure. Similarly, I will draw for another one. Another one, suppose I will draw for free radical. Free radical. What I will say? Ki suppose over here H CH2 dot. It will break like a dot, homolytic fission cleavage. What happens? This dot is there, this dot and this dot combined together to form a double bond. So over here you will get H dot, previously you are getting H plus, remaining you will get C H H double bond CH2. Over here, if anybody is asking electron orbital overlapping approach, what you will say? Sigma bond is going from where to where? It is going from sigma bond to P, but this time P is partial filled. Previously P is totally vacant because plus is there, but this time it is partial filled. So direct question coming in the exam कि in cation what is the orbital overlapping approach? तो sigma bond to vacant P. In free radical what is the orbital overlapping approach? Sigma bond to partial filled. Similarly they will ask for boron, CH3 BH2. What you will say? Same thing sir. Over here H plus, CH2 will be left, double bond BH2 coming, H plus means H is there, I am not writing that H, I have written inside it, it is similar to vacant orbital. So what you will say? Sigma bond going to P, this time again vacant, not partial filled. It means what is the situation of cation is the same situation of boron. Now fourth one understood. In the fourth one what is happening? Suppose I will write the structure CH3 CH double bond CH2. Now over here what will happen? If you will see this structure very properly understood this part, over here everyone has a confusion. What is the orbital overlapping approach? C H H H is there, any problem up to that? No sir. Over here CH double bond CH2. तो फर्स्ट ऑफ ऑल सिग्मा बॉन्ड तो गोइंग सर, हाँ सर सिग्मा बॉन्ड इज गोइंग, बट प्रीवियसली देर इज अ वेकेंट ऑर्बिटल क्लियरली देयर प्लस और डॉट, बट ओवर हियर नो वेकेंट ऑर्बिटल. तो यू हैव स्टडीड केमिकल बॉन्डिंग एंड मोलिकुलर स्ट्रक्चर कि वेन एवर पाई बॉन्ड इज देयर they will present in bonding molecular orbital, where it will present bonding molecular orbital, molecular orbital, and at the same time that is also written as BMO, chemical bonding and molecular structure, and at the same time there is a anti-bonding molecular orbital, at the same time there is a anti-bonding molecular orbital, and bonding molecular orbital is denoted by pi and anti-bonding molecular orbital is denoted by pi star. This is known as anti-bonding molecular orbital. So understood this part. Previously clearly there is a plus charge, so you will say going to plus. Over here clearly dot, over here clearly vacant orbital, but whenever electron is filled, so it is going from sigma to anti-bonding, and anti-bonding is pi star because double bond is there. So this orbital overlapping approach is from sigma to anti-bonding because bonding is filled na, double bond, no vacant is shown over here na. So whenever it will go from sigma to anti-bonding molecular orbital. Similarly, if I will do for fifth one, understood na? Those who not understood, chemical bonding video I will give, over there you will see bonding and anti-bonding molecular orbital. But for now understood, keep double bond and triple bond has anti-bonding molecular orbital because atomic orbital is filled. So electron will go from sigma bond to anti-bonding molecular orbital, that is pi star. Pi star is anti-bonding molecular orbital. Same thing you will do with triple bond, H, 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 C, triple bond, CH. So this electron coming sigma bond going to, over here already filled, so it will go to pi star. Similarly you will donate ki sir this is already filled triple bond, where it is left, so it is anti-bonding molecular orbital, electron will go in anti-bonding molecular orbital. Similarly, Nathan Baker has done the experiment, understood now, orbital overlapping approach for carbocation, free radical, and boron is sigma bond to vacant orbital for carbocation and boron, for free radical sigma bond to partial filled, and double bond triple bond sigma bond to anti-bonding molecular orbital, anti-bonding molecular orbital. Now Nathan Baker has done one experiment. We are going to see what is going to be happen over there. Over here Nathan Baker has taken benzene ring. In that benzene ring it has H over here, have na, it has hydrogen over here, hydrogen over here, hydrogen over here. Now in this part in this part, suppose I will do hyperconjugation. What happens? Electron will go from sigma, same overwrite, double bond is there, so same you will write कि sigma bond to anti bonding molecular orbital, that will not change. It is the fixed orbital overlapping approach. Now it will not going to be changed from this. Okay. ठीक है. Now over here it will go from here to here. After going, what means always sigma bond to pi star is not the problem, but understood the things very clearly and properly. It will come here. So what happens? This bond will go there. After this, what you will get? O, re, p, a. Double bond coming here as a negative, one double bond. Over here you are getting negative charge. Hydrogen is there, this hydrogen will get plus. Now inside the ring, this double bond will come here, this double bond will go there. What we will get? O, re, p, ya. This. Over here negative charge. Over here C, H, and not plus here. By mistake I have written plus here. It is not here plus. It is H plus. Over here H plus. Now again this will go here, this will go there. What we will get? We will get over here benzene ring. With that benzene ring, double bond coming here, negative charge coming here. Over here carbon, hydrogen, H plus. Acha sir. Over here double bond is already there, so that double bond don't remove. Again this double bond come here, this double bond go there, and what you will get? C, H, and once the double bond will come, hydrogen will again attach over here, and this ring will be completed. Means understood this part. What is happening? Over here, how many alpha hydrogen it has? It has 3 alpha hydrogen. But when one alpha hydrogen will entered, what will happen? One hyperconjugating structure, another and another. This is the original structure, na, coming like this now only. So no need to draw this. This is original one. I have drawn it, but understood the point what I am trying to say. First of all, atomic orbital overlapping is sigma bond to pi. Okay, sir. This I understood. But whenever one alpha hydrogen is going inside, it will do 3 times resonance. So previously, whenever I am asking CH3, CH2 plus, I am asking what is the total number of alpha hydrogen, that is the number of hyperconjugating structure. But in the case of benzene ring, if anybody is asking what is the total hyperconjugating structure, what you will say? Number of alpha hydrogen? No sir. Why? Because one alpha hydrogen will do resonance 3 times. 1, 2, 3 times. So 3 into number of alpha hydrogen. This understood? See, I am going a little bit deeply, but don't get confused. I am trying to make you understood the topic very clearly and crystal. I don't want to give a sit that 15 minutes completed and you are not able to solve the question. So in the case of benzene ring, 3 into number of alpha hydrogen. But in the case of normal, it is simple number of alpha hydrogen. Now next important point, you know that suppose I will increase the benzene ring over here like this, over here CH3. So where this position, everyone knows that this position is known as ortho position, this position is known as ortho position, this position is known as meta position, this position is known as meta position, this position is known as para position. If we will see the hyperconjugating structure on ortho negative coming, on para negative coming, on ortho negative coming, it means from here you will write ki hyperconjugation will increase the electron density in benzene ring at only ortho and para position. Hyperconjugation does not affect on meta position, because meta position not coming. So if any electrophile will come, positive charge will come, where it will attack? It will attack on ortho and para position. So electrophile will attack on OP, ortho and para position. Understood this part? Now Nathan Becker experiment. Over here first question CS3, over here second question this, over here, third question, this, over here, fourth question, this. Now if anybody is asking कि over here how many alpha hydrogen, sir 3 alpha hydrogen. How many hyperconjugating structure, sir 3 into 3, because 1 alpha hydrogen will do 3 times, so 9 hyperconjugating structure. Over here 2 alpha hydrogen. How we will check? Close the benzene ring, just after that carbon is alpha carbon. Close the benzene ring, just after that carbon is alpha carbon. Close the benzene ring, just after that carbon is alpha carbon. Close the benzene ring, just after that carbon is a alpha carbon. Over here 2 alpha hydrogen, so hyperconjugating structure is how many, sir 3 into 2, that is 6. Over here how many alpha hydrogen, sir 1 alpha hydrogen, so hyperconjugating structure, sir, so sir 3 into 1 is 3 hyperconjugating structure. Over here 0 alpha hydrogen, so hyperconjugating structure is 3 into 0, that is coming 0. So that whenever electrophile has to attack, it will attack more in this and then this. It means we can say कि the priority of H hyperconjugation is more than inductive effect. It means hyperconjugation is the strongest effect, inductive effect is the weak effect. So hyperconjugating structure is more in electrophile will more, means overall hyperconjugation is more powerful than inductive. So effect of hyperconjugation is more than inductive effect. I hope you understood up to this bakwas what I have done. If anything not getting, try to see another time. You will not get confused. Only last topic, then we will do the question. Only one question is there in our syllabus, that is called reverse hyperconjugation. Reverse hyperconjugation. And reverse hyperconjugation will be only seen in CCl3. Other than that you will not see. What do you mean by that? Over here suppose I will draw benzene ring, and over here Cl. Previously what happens ki double bond is taking the electron, but this time chlorine is more electron negative, the chlorine will take the electron. Because of that this electron will come, and over here what you will get? Over here Cl, carbon, double bond to come, carbon, double bond Cl, and over here Cl minus and over here plus. Similarly this will come here again, same 3 into number of alpha chlorine. Over here I have to check number of alpha chlorine is how much? 3 alpha chlorine. So how many hyperconjugating structure? 3 into 3, that is 9 hyperconjugating structure. How, sir? This plus will come here, double bond, Cl minus, then this will come here, plus will go there, so over here plus, there double bond Cl minus, over here double bond, so like that we have drawn, over here double bond, then again it will return back, hyperconjugating structure will be completed. But in the case of reverse hyperconjugating, what you will say, what is the orbital overlapping approach? So first time pi bond is going, see na, previously sigma bond is going to pi bond, first time pi bond is going to sigma, but this sigma is filled, so what you will write? Sigma star. Whenever anything is filled, it is going to anti-bonding molecular orbital. Why, sir? See, every place here sigma going to pi, sigma going to p, sigma going to p, sigma going to pi star, sigma going to pi star. Every place sigma electron is going to pi or some place, but first time pi electron is going to sigma, so it is known as reverse hyperconjugating structure. Now in this situation, if electrophile has to attack, sir, where it will attack? This time it will attack on meta position. Are sir, you are saying it is ortho and para reacting group? Yes. Where the plus sign will come? Ortho, para, ortho. Plus sign is coming on ortho, para, ortho. It means electron is going decreases in ortho, para. At least meta not decreases, na. So this time electrophile will attack on not ortho and para, because ortho and para is already electron deficient. So how other electron deficient will come? So this time it will attack on meta position. I hope you are understanding what I am going to try to do. Now this is all about the completion of hyperconjugation. Next some questions we will see. Job is done. Now we are going to see question and we will complete the topic. Sir, okay sir. Over here asking how many hyperconjugating, how many alpha hydrogen. Close the double bond. Over here alpha carbon, alpha carbon, alpha carbon, alpha carbon. This alpha carbon has how many hydrogen? 2 alpha hydrogen, because not written hydrogen, but you know that this alpha carbon also has 2 alpha hydrogen. This has 1 alpha hydrogen. This has 0 alpha hydrogen. So how many alpha hydrogen? 2 to 4 1 5 alpha hydrogen. How many hyperconjugating structure? 5 hyperconjugating structure. In this part, how we will check? Close the benzene ring. After closing, nearby this alpha carbon, alpha carbon, alpha carbon, alpha carbon. Now this alpha carbon has 3 hydrogen. This is not alpha carbon, by mistake I have written, 1 second. This is alpha carbon. This is alpha carbon. This alpha carbon has 3 hydrogen. This alpha carbon has 3 hydrogen. This alpha carbon has 0 hydrogen, because 1, 2, 3, 4 bond. This alpha carbon has 1 hydrogen. So 3, 3, 6 and 1, 7 alpha hydrogen. How many hyperconjugating structure? It is benzene. So 7 into 3, that is 21 alpha hyperconjugating structure, because in benzene ring alpha hydrogen is not the hyperconjugating structure. 3 into number of alpha hydrogen is the hyperconjugating structure previously dictated. Now over here again benzene ring, you will close this. This is alpha carbon, this is alpha carbon, this is alpha carbon, this is alpha carbon. This has 2 hydrogen, it has 1 3, it has 2 2 1 3 1 2 5, it has 1 6 alpha hydrogen. How many hyperconjugating structure? 6 into 3, that is 18 hyperconjugating structure. This you will do only in the case of benzene. Over here close this double bond. Over here alpha hydrogen, alpha carbon, alpha carbon. This has 2, this has 3, 3 to 5 2 7 alpha hydrogen. This is not benzene ring, it means it has 7 hyperconjugating structure number of alpha hydrogen. This is advanced question 2021. Over here this carbon is alpha carbon, this carbon is alpha carbon, this carbon is alpha carbon. So it has 3 to 5 and it has 1 6 alpha hydrogen. It means it has 6 hyperconjugating structure. When benzene, then we will multiply into 3. Acha. Carbon, over here carbon, 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 carbon. So over here this is triple bond. So over here this is alpha carbon, this is alpha carbon. This alpha carbon has 3 alpha hydrogen, this alpha carbon has 1 alpha hydrogen. Yani 4 alpha hydrogen means 4 hyperconjugating structure. Number of alpha hydrogen is number of hyperconjugating structure in normal. In benzene ring, number of alpha hydrogen into 3 is the number of hyperconjugating structure. Over here close this double bond. Over here alpha carbon, alpha carbon, alpha carbon, alpha carbon. This. It has 3 3 6 2 8 2 10 alpha hydrogen. It means 10 hyperconjugating structure. It close this plus. This is alpha carbon, this is alpha carbon. It has 3, it has 1 2 3 bond to 1. 4 alpha hydrogen means 4 hyperconjugating structure. This plus has alpha carbon this, alpha carbon this, alpha carbon this. It has 2 hydrogen, it has 2 2 to 4, it has 1 5 alpha hydrogen to 5 hyperconjugating structure. Close this double bond. Nearby that alpha carbon, nearby that alpha carbon, nearby that alpha carbon, nearby that alpha carbon. It has 2 to 4 to 6 3 9 alpha hydrogen. It means 9 alpha hydrogen, 9 alpha hydrogen. It means 9 hyperconjugating structure. No benzene, so we will not multiply 3. Over here we will close this alpha carbon, alpha carbon, alpha carbon, alpha carbon. 2 to 4 to 6 to 8, 8 alpha carbon. It means 8 alpha hydrogen. It means 8 hyperconjugating structure. So I hope कि hyperconjugation you have understood it very properly. If any single doubt, you can ask me again. I will dictate you, but I will suggest you to watch this video again, because I have given something very good regarding hyperconjugation, what I thought. Remaining you will see and tell, getting or not getting. Okay then, bye, have a nice day.